what we want to do today is we want to talk about writing functions, writing a sine or cosine function as the opposite function. So if I have a cosine function, I want to write that very same function as a sine function. If I have a sine function, I want to write it as a cosine function. So let's see why we can do that. It's hopefully intuitive. I have written here, in the red you see the basic cosine function. Y equals 2, the amplitude of 2, cosine of x, and then the blue, y equals 2 sine of x. So these are just written basic functions, and let's see why we can do this. If you notice, what's the difference between these two functions? If I have a cosine function, what does it take for me to get to a sine function, or vice versa? If I have a sine function, all I have to do to get to the cosine function is, all I need to do is subtract pi over 2 to go from the sine to the cosine, right? I just have to subtract pi over 2. Or, here I am at the sine, I could subtract pi over 2. Or, my other option is to get from the sine to the beginning of the cosine, is to add a positive, here I am at pi over 2, I could add a positive 3 pi over 2. That's the shift that I need to make to go from a sine to a cosine. Vice versa, looking down here, if I want to go look at from the beginning of a cosine function to the beginning of a sine function, I either need to add a positive pi over 2 or subtract 3 pi over 2. So visually speaking, that is the difference. That's the shift between one function and another function. Now, I don't really want to do that between two graphs though, right? That's not what we're doing today. So what I really want to do is let me show you, we were working on a graph the other day that this is a sine function. And I want to be able to write, just kind of, this is a little bit messy here, we got a lot of work to do on that one. I want to write this function, 3 sine 2x minus pi over 2. I want to write this very same function as a cosine function, because although this function is shifted and it's a sine, it starts at pi over 4, I see that I can start this function up here and look at it. It is a cosine function as well, right? It is a cosine function, and it intuitively seems to me that I should be able to write this function as a cosine function, and I can. So today we're going to learn how to write any function, whatever it is. If I can write it as a sine, I should be able to write it as a cosine, and you can. So let's learn how to do that. So I brought up these graphs because this is how we do it. So we're going to, if we have a sine function, we add 3 pi over 2 to the c value, or we subtract 2 pi to the c value. If we have a cosine and we want to go to a sine, we add pi over 2, or we subtract 3 pi over 2, and that is all there is to it. So let's do some practicing. Okay? So we're going to take, we don't even need to graph, I just wanted to show you those, but we're just going to do this. So let's take y equals 3 cosine 2 of x. All right, we're going from a cosine to a sine. So let's write that down. Cosine to sine. Therefore, what are we going to do? We are either going to add pi over 2 or subtract 3 pi over 2. Okay, so we'll do both. And what do we add to? We add to c. Well, what is c? c is 0. So we're going to take 2x plus 0, and we are going to add pi over 2, or we're going to take 2x and we're going to subtract 3 pi over 2. There wasn't much math going on there because we didn't have a shift to begin with. So now we've got our new shifts. These are our new shifts, and we're going to put them into our new function, which is going to be a sine. So we're first going to have y equals, we keep everything else the same, 3 sine, we've got our new shift, b stays the same, 2x plus pi over 2, there is no d value. Or we have y equals 3 sine 2x minus 3 pi over 2. Okay, well, how do I know that this worked? Let's test it. All right, we got to test it. So we're going to pull out the calculator. The first thing we're going to do is clear this out. Clear, clear, clear. We're going to go up to y equals 1. We're going to graph with a regular line the first function, 3 cosine 2 of x. 3 cosine 2x. All right, that's going to graph with a regular line. With a thick line, we're going to graph the second function. 3 sine parentheses 2x plus parentheses pi divided by 2. And I'm going to put that in parentheses to keep everything clean and neat. Parentheses 2, you don't really want that one. Delete. Sorry, I got an extra parentheses in there. I don't know why. Delete. Okay, so going back down there, 2x minus parenthesis 3 pi divided by 2 parenthesis parenthesis. Okay, now if all goes well, we'll see what happens. Graph. All better go well. Okay, first graph, second graph, and third graph. There we go. So we have all three graphs are the same graph, which is exactly what we were expecting, right? Because we have just written the cosine as a shift. We've written the same graph. It's just shifted over 90 degrees and 270 degrees, sorry, in the opposite direction, just like we said, right? We were writing the cosine to the sine. So we added pi over 2 or we subtracted 3 pi over 2. And that's what we did, and that is what we got. Let's do it one more time. I'm going to do it one more time, and then I'm going to ask you to do it yourself. So actually, you have this practice. We're going to practice. Let's do maybe a little bit harder one. Let's turn it over and do number 4. Okay? So let's practice this one. So let me make sure, we were going from cosine, so let's do the sine. So now we have a sine. We're going to go from sine to cosine. So what do we do? Well, we are either going to, we're going to both add 3 pi over 2 and subtract pi over 2. Okay, so what do? We take x plus pi over 6 and we add 3 pi over 2. And we take bx plus c, x plus pi over 6, and we subtract pi over 2. Okay, to get our new shift, we are going for the new shift. I'm going to write new shift. We need a new shift. Okay, new shift.